Okay, Wildcat, so we're looking at journal, page 16, graphing absolute value functions. Absolute value information. If the distance from 0 makes value positive, f of x equals the absolute value of x. The parent function, the domain is negative infinity to positive infinity. The range is bracket 0 to infinity. And I just thought about this. Makes the f of x value positive. Okay. All right, absolute value transformations. All right, the parent function is f of x equals absolute value of x. F of x equals negative a, absolute value, negative b times x minus h plus k. When the negative in front of the a, it reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative in front of the b, inside of the absolute value, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. When it's a minus k, it translates down. If you would, go ahead and update your notes. Okay, now your notes are updated. Let's take a look at examples. Journal page 16, graphing absolute value functions. Example 1, graph g of x equals 3 times absolute value of x minus 5 plus 4, and list the transformations. And then graph h of x equals 1/3 times absolute value of x minus 5 plus 4, and list the transformations. Now, first off, whenever we're talking about transformations, we need to graph the parent function because the transformations are based on the parent function, okay? Now, to graph this, okay, let's go ahead and first move the vertex, okay? We know that this moves it right 5, up 4. So from the vertex, okay, we go to the right 1, 2, 3, 4, 5, up 1, 2, 3, 4. And let's count it again. So 1, 2, 3, 4, 5, up 1, 2, 3, 4. Now, it's pretty simple from here, okay? If it wasn't for this transformation right here. So because of that, we're going to use Desmos, okay, to graph that. So let me come to Desmos. So we're going to type in, I'm going to use f of x in Desmos. I don't think it accepts g of x. So f of x equals, I'm going to hide that, and then, oh man, I need the, hold on. Oh, I don't need the drawing feature, so let me get rid of that. That's the feature. Now, this is the absolute value key. So now we're going to type that, x minus 5, click to the right, plus 4, enter, okay? And then I'm going to minimize this, and then now we have our points, okay? So we just check 5, 4 is right here, okay? And then, oh, wait a second. Almost forgot there's a 3 in front. There you go. And I'm glad I made that mistake because that might happen to you. Make sure that after you've graphed your talking points, go back to here and just double check one more time to make sure that you've typed the function incorrectly. Because as you can see, what I just did is I forgot the 3, and that could happen to you. Okay. So now we have this point that verifies 5, 4. Okay. Now the next point, you want to graph points that work. This point right here looks like it works. Okay. So this point, these are kind of by one. So 1, 2, 3, 4. This point is 6, 7. So that's 4, 7. So let's graph that point. So, and this is also, looks like 6, 7. So let's graph the points 4, 7, and 6, 7, and we'll come back to Desmos. Okay, so 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7, and 6, 1, 2, 3, 4, 5, 6, 7. And those are the only 2 points we really need. Okay. All right. Now, before we graph h of x, let's go down and look at the transformations, okay? So we know, we know that that's a vertical stretch of 3, that's right 5 units, and that's up 4 units. So let's write those down. So we have a vertical stretch of 3, that -5 is to the right 5 units, and then that's up 4 units. Okay. All right, now let's graph h of x. Okay. Now here, the -5 and the +4 means we go to the right 5, up 4. So it's at the same vertex. Okay. I did it on purpose. I'll tell you why in just a few minutes. Okay. So now let's go back to Desmos and let's graph this. Okay. So this is now 1 divided by 3, still x minus 5 and +4. Okay. So now we want to find points at work. This one looks good, and that is, it looks like 2, 1, 2, 3, 4, 5. So 2, 5. And it looks like, let's see, 6, 7, 8, 5. So 2, 5, and 8, 5 are our points. Okay, so let's graph those. Okay, so 2, 1, 2, 3, 4, 5, and 6, 7, 8, 1, 2, 3, 4, 5. Okay, and that's really all the points we need. Okay, now I did this on purpose so you can see the difference between a vertical stretch and a vertical compression. Okay, so let's go ahead and write that down. So the 1/3 is a vertical compression of 1/3. Okay, and then it's right 5 units and up 4 units. Okay, so go ahead and finish up your notes. All right, I'm sorry, not notes, example 1. All right. Now let's take a look at example 2. So still general page 16, graphing absolute value functions. Okay. The yellow and green away. All right, graph w of x equals absolute value of 3x plus 5 minus 4, and list the transformations. Graph t of x equals absolute value of 1/3 x plus 5 minus 4, and list the transformations. Okay, so again, you always want to graph the parent function, okay, because the transformations are based on that. Okay, so first off, this tells us that we move left 5, down 4. So let's do that. So left 1, 2, 3, 4, 5, down 1, 2, 3, 4. Okay, so there's a new vertex. Okay, now because of that 3 in here, it's going to be the most efficient way to graph using Desmos. So now let's change this to take away that 3. The 3's here. This is a plus 5. And then this is a minus 4. Okay, so 3. And again, you want to double check, do you have that right? 3x plus 5 minus 4. And I'm going to move my graph here. First off, let's make sure that, hold on. All right. Let's see something. 3 plus 5 minus 4. Now, you'll notice that this made getting the vertex more complicated. It's not actually that. Okay, so I'm going to come back and change that point. Okay, and you'll notice that the horizontal stretch and compression make things a little complicated. That's why I'm using Desmos to get the graph. That vertex is a little hard to see, and let's get the point there. They're saying negative 1.67, negative 4. Okay, so let's see. And I'm going to make sure, again, I typed it in. Okay, so now let's come over to here. Let's get that. So negative 1.7 and negative 4. So negative 1.7, somewhere about here. 1, 2, 3, 4. So the graph's right there. Okay, So you'll notice we originally went here, but you can't do that when you have horizontal stretches or compressions because that changes, okay? Now let's get the point. Okay, so it looks like we have -3, 0, and -1. So that's not a really good point. But 0, 1 is a good point. So let's go ahead and graph -3, 0, and 0, 1. Okay, so -1, 2, 3, and 0, 1. Okay, and again, you notice these, so it gets a little complicated when you're doing horizontal transformations. Okay. And let's go ahead and list those transformations. And I want to review my notes. Oh, that's the example page. Now you'll see that we're looking at the B value, and in this case the B value is greater than 1, so it's a horizontal compression. Oh, sorry. The B value in this case is 3, so it's greater than 1, it's a horizontal compression. Okay. So we have a horizontal compression of 3. Okay. And then we went left 5 units, and we went down 4 units. Okay. All right. Now let's take a look at T of X. Okay. Now I'm not going to make the mistake that I did before where I did the transformation, where I moved the vertex, because this changes where that vertex is, and it's not that simple. Okay. So now let's go and type that into Desmos. So now this is 1 divided by 3, x plus 5 minus 4. And let's zoom out. Okay. Now you notice as soon as I click on the vertex, okay, it gives me that point, -15, -4, and it gives me this point, and so -3, 0, and -27, 0. So that point's a little too far out. Let's see if we can find a point that's wow. All right, so let's go in here. So -15, -4. All right, so -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, -1, 2, 3, 4. Okay. And then, let's see, -3, 0. -1, 2, -3, 0. That point works. Okay. Now, looks like we're just going to have to approximate this. Okay. Now, it's hard to see the left side here, but you can very much see that this was a horizontal stretch. It's stretching it out quite a bit. Okay. So we know that this is a horizontal stretch of 1/3. Okay, and let's just double check the notes, be sure, but it says right here, 1/3 is greater than 0 but less than 1 horizontal stretch. Okay, and then it is to the right. Oh no, I'm sorry, left 5 units. And down 4 units. Okay, and that's a terribly written 5. Okay, go ahead and finish up your notes and have a wonderful Wildcat day.